Hello. This lecture is about part 2 of software concurrent software development models or software stability models. This is part 2. And this is, very important for you to follow this and actually try to understand what I'm doing. This is related to the best methodology in doing anything. Software systems, think about the problem. This is the best. By the way, this is again, I just done with the lecture 1 and this is lecture 2. Let's go through this and see what we have to talk about here, by the way. So this is usually 3 pages about me, and this has a lot of different, something I don't know, it happened this way. And we're going to show the objectives. The objectives here, as you can see, enduring business themes and business objects, which cannot be shown into the existing development. This is required for you to learn how to do a lot about this. Industrial object, that's what we do everything on, the concept we use. Identification criteria, identification heuristics, which is heuristic is part of what I do with everything. Silver bullets, I'm going to talk about that because again, everybody say we have no silver bullet in software engineering. We will see now if we have some or not, Intelligent stable analysis patterns as an application, as an example, to show you what's going on. So this is again in enduring business themes. This is again unified words, and this is again, it's not concepts. Does not appear in traditional model ever, by the way. Stable, final, continuous, cannot change anything. This is actually is an encapsulated knowledge we live by and we use it all the time. So it's an ultimate goal of themselves, has rules of conducts, high levels. Rules must be known to all. Unfortunately, many people do not know them. The rules of those fantastic words we live by. Important discoveries in it, which is actually a lot of discovery. More than 50 discoveries and more than 300 innovation for each word. And a new knowledge, cognitive knowledge, able to exist. Example, friendship, love, marriage, thinking, retaliation. This is a lot of words here. I would claim we don't know anything about them. Or if we know, it's not complete. Because again, our knowledge related to tangible stuff all the time. And actually in our mind, we're not really paying attention to those wonderful words, by the way. So ABT interact with a BO and do not interact with IO. This is again 3 layers. The nucleus of the layers is an ABT. Could look at it this way. Then connected to the BOs. We're going to talk about BOs right now too, by the way. To show you, here is the BOs. BOs is actually also unified words. Stable internally and adaptable externally. They both black boxes. Cannot touch it. Adaptable externally means you could overwrite, you could really add a few things externally. Do not really get into the internal structure of it. Very final. Has a beginning and end. Each word has a beginning and end. Has an ultimate goal that can be positive or negative. We have to find an ultimate goal for. This is an art of abstraction for the first discovery is the ultimate goal. Because the ultimate goal is the beginning or really start functional, non-functional requirement, how to model it, how to do things with it, by the way. Has rule of conduct, moderate level. Rules must be known to all. Unfortunately, a lot of people don't know the rule of conduct of any business object. None. Important discoveries, example, any project, any proposals, any cultures, any data. And actually, this is each one of those. We have each business object, we have more than 50 discoveries, 300 innovations, and more than 100 cognitive informations or knowledge. In this case, EBT interact with BO and BO interact with IO. In our models, when we build it, I'm going to show you examples. There is thousands of examples, by the way. So this is again, now this is IOs, which is a concept we use. See, I'm building the two layers, EBTs and BOs, then I connect it to the tangible object we use in our system. This is the traditional models. They call it industrial objects or application objects. This is actually, I think it's written here, is not a BO, is an IO. Is a mistake here in my presentation, sorry. So an IO interact with BO only. Has nothing to do with the EBT. You see? This is a changeable. That's what we build the system on all the time. Tangibles, unfortunately, and currently build and develop everything based on them. Disaster. This is a great disaster, by the way. This is really bad. Application objects, when known to the majority of people, you can touch it, you can feel it. This is again in front of you. It's very obvious. So it has no value. This is actually, describe this to me. For example, when you buy a car, the car reduced its value a lot. But again, if you really go into under and you don't have any money and you announce bankruptcy, this car doesn't mean anything. Many companies go broke. All the building and everything they have is nothing. This is really big, bad. Then they're not really living for a long time. This is again things which is changeable and tangible. Has no value. Strange things people say, I love my car. What? This is very semantically wrong. Because love is not for your car. Love is an enduring concept. And this is for your family, your mom, your dad, your kids, your God, your prophet, whatsoever. Not for a car. This is again, this you might appreciate it. This is fine because this is again, it's a toy. It helps you from one place to another. This is actually insane. And what I love smoking. This is crazy. This is nonsense. This is a bad habit, by the way. Some of them have side effects or high impacts on society, such as oil, drugs, and stuff like that. This is an industrial object. And all the dilemma we have in our life are industrial objects. We have no clean air because of oil, because of the change of environment, because we did a lot of damage to the nature, which is actually wonderful, amazing. It's all based on EBTs and BOs, which is not appearing anywhere in the traditional development. Example, specific novel, specific table, MacBook, for example, this is what we build. Any system that way. We build the instance of things. And we have to name it too, by the way. So this is again insane. We build a lot of machine learning. The market and actually the cost and the number of really people and company work on machine learning, huge, billions of dollars. Market is even a lot bigger. How many company doing machine learning? If they all the same, what's really, which the one is the best or good? It happened through the history. We have search engine. We start with search engine. It's a long time ago now existed. Now this is again, there is a lot of project and actually done for research engines. The only known is a few. Some of them just kind of really gave up. There is still some, most of them exist, but again, they're hoping to make some money like every other things. How many languages we developed in computing? Thousands, more than 33,000 languages been developed in research, in market, in many different places. This is amazing. And actually, this is all doesn't contribute anything what we do. We need to expand more. We need to start concentrating on this way of building systems. EBTs and BOs, this is the heart of things. You could build patterns and engine this way. This is a whole entire life cycle, by the way, too. So, IO interact only with BOs. So, let me see. This would create a core knowledge. And this is very important. When people say the software engineering and knowledge engineering, knowledge engineering, software doesn't have any knowledge because it's actually based on concept, my friends. It means tangible stuff. There's no knowledge there. The knowledge encapsulated in the functional, non-functional requirement, and the ultimate design. Yes, you might really debate with me and have some knowledge. Yes, they do, but I'm talking about the knowledge we need to build on to stabilize our development of everything. Even in actually any problem you have, use this, and I'm going to show you in the lectures how to use this for anything you do in your life. This methodology. And actually the discovery I did for every word and every domain. So core knowledge is a unified knowledge for the word and for the domain. All the domain analysis done is an instance of domain, an instance of an application which is about concepts. This is no good. So, and then we have a lot of people, and actually I have to present to you what really the critical looks at domain analysis and many different things we do. This is anyhow in software and system engineering. So core knowledge is a mix of EBTs and BOs, or EBTs plus BOs. So it could be BOs, EBTs, all of them, or could be a mix of both. So a mix of BOs, or a mix of EBTs, or a mix of both. EBTs and BOs. And this is just a simple thing too, by the way. For example, we have data analysis. This is actually a known phrase. This is actually, it has analysis is an EBT. Data is a business objects. Now, this is very important to look at, by the way, because again, you must know this knowledge to build a stable and enduring systems. And you could really keep using it all the time, not for a few years, not as soon as you people compete with you, you're out completely. This is again, this is such a wild things, by the way, what we do. So, EBTs and BO identifying criteria. We need to see stability. adaptabilities, essentialities, explicitness, and intuition, tangibility, and common to the domain knowledge. Look, this is a criteria I'm going to compare now between the ABTs and BOs and IOs. Because IO is what we use right now. So let me see. So in this intuition exists in only the ABT. It doesn't appear in traditional models, by the way. Intuition and in reading. So you cannot use this personal object until you really have, things. This is in your knowledge. Then from reading, from investigation. Industrial objects appear to you from reading any document. That's why the document given to you, they told you this is a requirement. This is not true because, again, this is industrial objects, intelligent objects. And what you build is just an instance of the application. You see? So the second one here, which would be stable over time. The first one is stable over time, forever. Never change. Now, internal stables, the business object, unstable. This is again, it's not unstable, by the way. This is again, it's very in time and things. Adaptability, this is adapted without a change. EBTs. BOs adapted through external change. See? So the other one here, which is I leave it on purpose because when you read the column, the first one here, internal stable. I leave it that way. The reason for that, because unfortunately, I did a mistake in my column in as a communication with SSM. So I'm telling you the problem there. As a note, this is, I made purposely this way to really tell you this internal stables, and this is adaptable externally. For example, this black box, and you could adapt it by overrides and do things, and you could really be able to achieve the goal you have for specificity. The industrial object is not adaptable. Remember this. So, extensibility, essentiality. EBT is essential, must be there. And actually BOs is essential too, by the way, because again, this is what really, we're talking about the goal of the BOs, because if this BOs is not there, you're not building a system. And you have to find a goal for BOs, or it's replaceable. This is the comparison you can use. Coming to the domain, this is core, this is peripheral. Now, tangibilities, conceptual, and this is written because, again, people think about it, but it's not conceptual. This is actually a word generation. I wrote this because people think that way. Semi-tangible, because we have in BOs, we have human. We cannot make human replaceable. It doesn't make any sense. We have parties, which is by laws, exist. This is a valuable thing. This is business objects, organizations, government in a country, parties have legal. That's why we have it as a business object. And this is again all the attached, the BOs are tangible things like machines, creatures, and what's it keep going. This is what the whole entire thing explicitly. When you read the problem statement, it's not there, the EBT, implicit. But when you read for BOs, you try to really sometimes explicit. Like, for example, the actors, the party, the roles, stuff like that. And this is again, but industrial object always explicit. So if you take industrial object there, This is all the concept, by the way. And this is all what you use in developing software, which is a problem, a dilemma. So let me show here what really identify of enduring business themes. Enduring business themes and business object must be enduring. To make the development enduring, to make the system we build enduring. Time comes to do that. This is a must know, do this. Because again, for example, the computer in front of me here, which all the computer use, have the same thing. The only thing is that change the look and it changes the board. That's it. And sometimes the battery, sometimes the camera, sometimes, but they sell it to you for the same price. The same for software. And you have maintenance license you have to pay for it. This is enough. We are tired of this. Watch out for long field historically histories, because it will not be necessary to translate into true endurance, by the way. We're talking about words here, not a long field of things there, by the way. So, how about for I/O? I saw now the important about EBTs and BOs. I/Os is the object presented in a classic or conceptual models. This is a unified word, concepts. So when we go back to the others, let's leave it like this, because again, I'm not talking about conceptualization here, because it's always misconceptualization. Can the object be replaced? This is again, obviously, yes. Is the object a representation of concurrent object? This is again, concrete objects? Yes. This is what the I/O is all about, by the way. So we go here and see, this is again top down. Now I can do this in many different ways. And I will show you by example now. So I could start breaking the problem into unified words. You start with enduring business themes. That's what I'm supposed to do. This is again, I could really start with the business objects. But what would I do? I go back and actually try to find the ABTs. This is a process, by the way. Then I found the rest of classes with BOs associated with the BO. Then I just go out and I still stop until I reach the concept, which is industrial objects. I could do it top, bottom up, right there. This is again the same thing. Start from classic conceptual models, concepts. Then I take group the concept to really make a BOs. What does concept belong to, by the way? You see? Then what I really do, the BOs, I group this into an ABT, which is really be, and I could go further until it's impossible to do. 3 layers, up and down. This is again how you do it. So, is there a silver bullet here? Yes, and some in the new stuff. EBT, enduring business themes, a continuous unified word, usually. This is definitely yes. This is actually a silver bullet. Business objects are enduring business objects that are adopted externally. Silver bullets. What we're building every time on the software, industrial objects or application objects, they are concept. They don't have a silver bullets. No way. That's where the silver bullets come from. I'm writing a big chapters about this to show you the difference when how do you achieve a silver bullets in your development. This is a must do. We do everything in software, there is no silver bullets. Therefore, we have a lot of problem. You see? This is has to be guarantee the endowment of this system you are building. It's going to continue forever. supposed to be. And actually could really be the use and everything. And you could really change the application on top of it very easily. You not have to build from scratch as re-engineering. This re-engineering stuff is really terrible too, by the way. I've been in a project like that. And actually, this is crazy. We're going to re-engineer and re-engineer and engineer forever. Doesn't make any sense. So this is the way to build. So you take EBTs and BOs and build the engines. EBTs and BOs are patterns. Then you could build an engine or system of patterns this way. Unified system of patterns or system of unified patterns, whatever you want to call it. See? So this is again, this is an example. This is intelligence. This is an enduring business themes, and actually this we call it stable analysis patterns. I start here. This is actually the intelligence and EBT there attached to the BOs. All the BOs here are the knowledge exists to achieve this intelligence. That's all the BOs there. Then I could attach application to it. Look at the two applications coming here. This is actually the function requirements. I have a non-function requirement for that is are executable. They're actually diagrams. This is actually has to be executable. But now I'm trying to show you something very simple, very quickly about one patterns. Then I come really see here. That's the first application, intelligent, stable analysis patterns, Google Map. I have the scenario and everything. Then I show you this pattern is the same, never change. There is no any cross lines or things like that. What happened here? Yes, this is not a cross line. This is a boundary. That's an EBT BOs. This is an IO. This is IO. This application there. There is no cross lines at all. Just a boundary here. This has nothing to do with the model. Just to show the template for putting the model in. So EBT, UML, if you have cross lines in UML models, this model worth nothing. Telling you that. This is again, they have a way for now to do it, stuff like that. This is means you have unbalanced models right away. Just an idea very quickly. Look at the first application here. This is the same patterns. This is actually the application right there. Look at the second application. Look at the second application, application 2, which is actually Tesla autopilot systems. This is a model there. Right there, this is the intelligent there. This is actually the application right here. The same patterns. Nothing changed. This is how we're going to build worlds and systems and engines and how we analyze and actually capitalize on the domain knowledge using knowledge map. This is to show you. And the whole entire idea, this methodology I'm presenting is the base what I do, everything. See, this is again, look at this. I have a serious need here. The proposal is ready to be submitted to NSF. Unfortunately, the people they are working, they don't really know. They cannot get this. This is too much for them. I'm telling you because, again, I've been there for a long time. I've been several times there for NS reviewer, and actually in different agencies. But unfortunately, all the research been done, to be honest with you, is a waste of money. Billions of dollars. This is again, people build research and ideas. It does not exist anymore. This is nonsense. We have to start building on something that's going to be continuous. It's going to be enduring. Otherwise, we're wasting our money and energy and everybody, they come write a paper. You're talking about people in conferences, like he did a gift. How many papers we generate in software engineering? I wonder How many research been done in software engineering? How many books been written in software engineering? How many systems were developed based on the concepts or the industrial objects? It's insane. So, looking for the following: partner individuals, professionals, practitioners, academics, universities, software organization, training, and government organization to really work with me on these proposals. This is very important because, again, this is a gifted methodology. It brings us to the right track. And this is, I'm looking for endorsement letters. Please contact me. Please contact me urgently. I need to do this and partner with me. And also, right, this is again, if you're in software engineering or maybe in any system development, you need to learn that stuff. I need to provide a lot of information for everybody to learn it. I already have a course on to offer in any universities and any companies, by the way. And actually work this course on a project exist to show them how to use it. And actually one of the things here too, by the way, you don't have to do any documentation. The only documentation you need is the engine documentation. Don't document the IOs. This is no documentation for concepts. I remember we wrote a roll of documentation in one project I work on in military, and this is every page was a lot of money, talking about millions of dollars. And those documents are useless. And we used to call the documentation as the lamb. And now in this case, the document knowledge, which is very valuable. Don't document industrial objects. It doesn't make any sense. So the manual of the car, nobody open it. This manual is a gift from the company to you. I never opened the manual of any car I bought. And I would not understand it too, by the way. This is maybe the mechanic would really understand it better than me. This is not really easy. Just to write a technical report about the system. Nonsense. The system has to be intuitive the way you have to use it. And this is again a waste of money and time, and people throw it away. Every device and everything I bought, the manual I don't have. Even the camera, this is nonsense. The internet now could really figure out a lot of stuff, by the way. You need it. Just a manual, you pay for it and you don't need it, believe it or not. So this is actually a conclusion, and this is a comeback here and saying, this is another book, beside this book. It's a collection of all the columns I wrote on this area and answer a lot of questions from different people. Amazing. One of the columns received 1,500 responses. Participate. Please participate. Please communicate with me. Please offer me your help for endorsement letters or partner with me. This is for universities, companies, and individuals as well. Thank you. Appreciate it. You have a good day.